So we're talking about Chapter 2, forces. A force is the same definition you've used your whole life, a push or a pull. So the force of gravity, if you push a toy car, those kinds of things are all types of forces, okay? So statics is the study of things that are not moving, which is convenient for us. So everything we consider to be in equilibrium. Forces have units of pounds, kips, tons, newtons, and kilonewtons commonly. A kip, if you've never heard of it, is 1,000 pounds. Okay, so let's talk about two different types of quantities: scalars and vectors. Right, scalars have magnitude only. All right, they do not include a direction or an angle. These types of numbers would be things like speed, 40 miles per hour, where a vector has magnitude and direction. So a vector has magnitude and direction and would be velocity. For instance, if I said the car was going 40 miles per hour north, that is a vector. So speed and this would be velocity. Okay. Some other examples of vectors would be acceleration. And you could say north, south, east, west, to the right, at 30 degrees, at 270 degrees. Those are all ways of giving directions. Okay, so let's talk about components of forces. Here I've drawn just your regular Cartesian coordinates. This is your x-axis, and this is your y. Okay, and we have this force, we'll call it F. Okay, and that force has two components. It has an x component here and a y component here. Okay, so if we want to figure out and kind of graphically project those, we can go down like this and across like this. Okay, so now this is the x component, Fx, and this is the y component. Alright, so this is Fx, and this is Fy. Okay, and now if we know this angle, theta, okay, we can find the components of the force. So Fx is going to be equal to F times cosine theta. Okay? And Fy will be F times sine theta. Alright, now this is only true when this angle theta is measured from the x-axis. Alright, so don't forget that. Theta from the x-axis. that is super important. Okay, that part right there. Sorry, this comes out weird looking. Alright, so that's what I want you to be sure that you don't forget. That theta, no matter where it is, has to be measured from the x-axis. Okay? Alright, so let's work a problem. Okay? If we say that this force, okay, F is 100 pounds, okay, and let's say this angle is 25 degrees. Okay, we can now find the x component and the y component of this force. So let's look at that. Okay, this, what I've drawn here, okay, is going to be my x component. Let me change the color of that so you can see it a little better. Okay, and this is the y component. I'm going to draw that one again. Okay, so, alright, now you have f sub x and f sub y. Alright, and so these kind of, it's our dotted box again. That's called the parallelogram method. Okay, or we're just projecting these right onto the axes. Alright, so to do this one, it's going to be f sine theta, and this is going to be f cosine theta. Alright, so let's calculate that, okay? And, oh shoot, this calculator doesn't have trig functions. Let me get calculator from the accessories. Alright, be sure you're in degrees on your calculator, and you want to do, we'll start with Fy, we want 25 degrees sine, okay, and then I want to multiply that times 100. And so I get f sub y is let's look again. It was 42.3. And don't forget to use units here, guys. Pounds. Okay? Now f sub x is going to be let's clear that. Okay, and now I want to do 25 cosine, alright, times 100, and I get 90.6 degrees. Pounds, not degrees. 90.6. Right? Units are very important, so please do not forget them. Alright? Now, let's look at another example. Alright, we've got one more here to try. This time, this is 1,000 newtons. this is 50 degrees. I'm going to get you to take a moment now, and I would like you to find f sub x and f sub y. Okay, so your fx is equal to 1,000 times cosine of 40 degrees. Oops, I have to write a 0 before you write the degrees. Okay, now the reason it's 40 is because the angle I gave you here was measured from the y-axis. Alright, and our f sub y is going to be 1,000 times sine of 40 degrees. Okay, so if you put here 50 degrees, your f sub x and f sub y are going to be backwards. It's a very common mistake, but it will cause you a great deal of problem later in the course. So always remember, theta is measured from x-axis. Alright, so let's go and get those numbers. Alright, so we have 40 cosine times 1,000, alright, and we get 766. Alright, and then for this one, we get 40 sine times 1,000, and we're going to get 642.8. Alright, so the important thing to remember again is, please remember that theta, right, is measured from the x-axis, right? And that was a little trick because I gave you from the y-axis. Alright, now that you have broken a force down into its x and y components, let's talk about turning components into a resultant. Alright, so if I have two forces that look like this, and then I have a second force here. Oops. Okay. Oops. I've made a little mistake here. I'm adjusting the length of that one and I just want to move it. Alright, well we're just going to have to pretend like it starts at the origin, okay? And let's say that this is 300 pounds, okay? And this force is 150 pounds, alright? Now we need to find the resultant, okay? One way to think of the resultant is as the diagonal of the parallelogram, okay? Again, so that's back to kind of our little parallelogram method there, right? And here is our resultant. Okay, so there's our resultant, and now we need to find the both the magnitude and the direction of it. Alright, so in a couple of places here, we have a triangle. Alright, so we have this triangle. Alright, right there that I've just highlighted. Okay, and because we know that triangle, we know the length of this leg, and we know the length of this leg, I can use Pythagorean to find the resultant r. Alright, so we're just going to use Pythagorean's theorem. R squared equals RF 1 squared plus F 2 squared. Alright, so it's going to be equal to 300 pounds squared plus 150 pounds. Squared. So let's go to our calculator now, and we're going to do 300 x squared plus 150 squared equals. Alright, so that is okay, so that's r squared. Now what do we need to do to get r? We take the square root. And let's find square root on my calculator. There it is. And the square root is 335.4. Okay. Alright, now if we look back, we said for a vector we need a magnitude, which we have, and a direction. So we need the angle here. Okay. If I look at this triangle, okay, I can use my regular trig relationships, and I know that the length of this side of the triangle is my 150 pounds, and the length of this side of the triangle, okay, is 300 pounds. So if we use our trig relationships, what relationship do we have that relates the opposite and the adjacent? That would be tangent. Okay, the opposite is going to be 150. And the adjacent is going to be 300. Alright. So when I put this in my calculator, I need to use inverse tan or arctan, depending on what you want to call it. So let's do 150 divided by 300, 0.5. We already knew that. And now we need the inverse tangent right, and I get it is equal to 26.6 degrees. Right? So let's go back and write the general equations for this, okay? The resultant is equal to the square root of fx squared plus fy squared, alright? And the theta is going to be equal to the inverse tangent, or the arctan, of, and we said it was the opposite, so that's the y, so that's your fy divided by fx. Okay, so these are your two general formulas. All right, here. Okay, to find the resultant from x and y components. Okay, so let's try to find the next resultant. If we have a force here, and a force here, okay, and let's say that the x component is 200 pounds and the y component is 200 pounds. Now remember, we said that the resultant would be the diagonal of the parallelogram that these forces make. Alright, and so this is the resultant. Alright, so let's calculate the magnitude of the resultant. It's going to be r squared, remember, is equal to 200 pounds squared plus another 200 squared. Okay, and to get r, I'm just going to take the square root of that. So if we do 200 squared plus 200 squared equals, okay, so we have 80,000, and now we want to take the square root of that. Alright, so r is going to be our 282. Alright, so now we also need to find the angle. Okay, so we use our tangent relationship. is 200 divided by 200. And so theta is going to be equal to the arctan of that, whew, it's hard to write with just a mouse. Okay, let's look at that. Let's do inverse, let's hit clear first, and then we'll do 1 inverse tangent, and we get 45 degrees. Okay, so theta is 45 degrees. Okay, let's work some problems. Actually, I guess this seems to be the last slide, so I'll get set up to do another short video for you on some of the examples in the book.